In this video, we'll show you briefly how to get started with your projects for 3311. So let's just briefly walk over the outline for this video. So first of all, we'll show you how you can generate a new ETF project for the static analyzer that you're going to implement, and how you can switch between the command line mode and the default GUI mode for the ETF projects. And then we'll briefly talk about how you can add a new cluster by specifying the relative path as opposed to the absolute path to make sure your submitted project later will actually compile when we grade it. Because if your project does not compile when we grade it, you'll receive 0. So please make sure you pay attention to this small detail about how you can specify a new cluster in your projects if you want to do so. And then we actually show you a very quickly error reporting mechanism in the abstract user interface side, because on your business model side, you're going to follow the design by contracts mechanism as usual, but to actually handle error report, you have to do it from the abstract user interface to make sure when users actually interact with your application, if they somehow violates the preconditions of some features, your software would not just crash. Instead, from the abstract user interface point of view, they're actually going to report some error message and let the users to retry with their typing. And then finally, we're going to show you when you are doing while you're doing your ETF projects, how you can actually still use the debugger and setting up the breakpoint. It's still possible. You just have to set up some execution parameter in Eiffel Studio. We'll show you how to do that. It's actually quite simple. Okay, so now for you to get started with your projects, please go to the course website and then go under assignments projects here. And here we have the instructions for the projects which you have to study carefully in order to do your projects. And now we're going to download this starter. Okay, just download to somewhere. Let's say in my case, I'm going to download to my desktop. Okay, save it there. And then see it's a zip file, and we're going to unzip it. Okay, so this static analyzer folder is going to be the one you're going to submit when you are complete with your projects later on before the due dates. So you have to submit this whole directory later on. As we'll see, a slight confusion you might have later is if you go into the static analyzer folder, we actually have different files, and we're going to use this events files to generate your ETF projects. As we talked about before, this is the file where we define the abstract user interface in terms of the system name, which is static analyzer, and also this list of events that actually might occur to represent the interactions between the users and your software application. Okay, so that's this file here, and then we also have a README file. Please read it to make sure you know which file is supposed to do what. And we have 81, 82, 83, 84, 85. We have 5 use cases file. So here you can see for each of the 81, 82, etc. So they contain simply events that actually represents a single use case of your system. And for each one of them, we have a corresponding expected file. Let's say 81.expected.txt. So here you can see that we have exactly the list of events that we actually defined in 81.txt. But here in 81.expected.txt, before and after each event, we also have the printout of the abstract states. So how we define the abstract states, please refer to the instructions for your projects. Okay, so just make sure later on, when we grade your projects, we are going to run a list of other use cases file and make sure whatever output that is produced by your software is going to look something like this, and we're going to compare your actual outputs against the outputs generated by the solution executable, and we're going to make sure if they actually match, then you will get a mark for that corresponding use case. Otherwise, if they have any differences, then you don't get any marks for that particular use case. Okay, that's the workflow. So please make sure when you actually build up your software, you have to really make sure at least you have your software produce the outputs that are actually identical to 81.tx, 81, 82, and up to 85, right? So now let's see how we can get started. So the slight confusion I mentioned, which you might have, is later on when we generate the ETF projects using this static analyzer events file, we're actually going to have a subdirectory that will also happens to be called static analyzer. So when you submit your projects, please make sure you do not submit that subdirectory. What you have to submit is this top level directory called static analyzer. Okay, there will be no excuse if you submit the wrong folder. You will just receive 0 if you submit the wrong one. So please pay attention before you make your submission. Okay, so now let's see how we can generate your ETF projects for your projects. So you have to open up some command line terminal, and we'll just watch how this static analyzer is going to be changed by being added a list of files generated by ETF. Okay, so now let's go to, in my case, I store that in desktop, and then in static analyzer, go into it. Okay, so now we are in static analyzer, and we're going to run ETF. So if you're using a Prism machine, ETF will be available to you. And if you're using a home machine, please follow the installation instruction for ETF, and the ETF should also be available on your home machine. So ETF, we're going to generate new projects. So we say -new, and then we're going to use static analyzer events.txt, and then we're going to generate a project into the current directory. So that is why we're going to say dot. Okay, once we do that, we'll say enter. So now you can see that we now have many new things that are actually have been added into the static analyzer folder. And you can see that because we declare in static analyzer events.txt here, the system is called static analyzer. That is why there is a subdirectory also called static analyzer. So when you submit, make sure you do not submit this particular directory. You have to submit the top level directory on your desktop or whatever you actually unzip the folder. Okay, I cannot emphasize more. You have to submit the right directory for your projects to be at least assessed. Okay, so under static analyzer, you actually see there's a directory called model. So all your developments most likely will just go into it. Okay, go into model to develop your business logic. Currently, you just have ETF model and ETF model access. You have to use the renaming tool or simply delete the classes in order to put your own classes into the model cluster. Okay, and then when you want to do some error handling, because remember there's a separation between the business model and the abstract user interface. So in the business model, you're going to apply the design by contracts principle that we have taught so far, and the features of the classes under model cluster are going to have pre and post conditions. And if the users are trying to interact with your system in such a way that it might violate the precondition of some feature, then you have to somehow under abstract UI and user commands, you can see each of the events that is defined in this file here has a corresponding class. So this is sort of the command pattern which you actually learn from your lab test. And here for each one of them, so let's say if somehow, let's say, let me just choose this one, let's say division. So in this case, let's say the user, maybe this is not a great example. Let me say evaluates. Those will be a good example. Let's say this user decides to evaluate the current expression that has been specified. And if somehow the expression is actually a division and the divisor is actually 0, in this case, it would violate the precondition for the division. However, your system shouldn't just crash if the user happens to specify 0 for the divisor. So what you gotta do is to make sure in this class here, ETF evaluates, you have to somehow to say if the user specify a division and the divisor is actually 0, then I should really output certain error. I should set the error to the business model. Otherwise, if there's no error, then I can actually call the corresponding feature in the business model. Okay, that's and you have to do similar setup for all the other features in your business model. So you can see you have so many events to take care of for your project. Please make sure you do them thoroughly. Okay, so now we have to compile our projects, and remember the default mode for the ETF project is simply just GUI mode. So for your convenience, I think you may just want to override the default into the command line mode. I'll show you how to do that. So we're going to compile in Eiffel Studio, so in Studio 1501, and then we're going to get static analyzer.ecf. Okay, just as usual, that's how we compile the projects. And let me just browse to that. So you have to go to desktop and then go to state analyzer. Okay, and we compile. It's going to take some time. And of course, you have to always make sure while you're developing your software, please make sure you also back up your software just in case anything bad happens before the due dates. Okay, for the first time, it's going to take a little while. But one more thing, so you can see that, so here, while we are compiling the projects, it's actually going to generate the ifgen folder. And inside the ifgens, because currently we're only trying to compile the projects without finalizing it, so you can see under ifgens, we have a folder called static analyzer. Under static analyzer, so the folders you have to pay attention to is either F code, so F stands for finalized. And here, W code, W stands for working. So either it's F code or W code. So in Eiffel, there are two options for compilation you have to pay attention to. One is the normal compilation without finalizing your projects. And the other one is when you are trying to finalize your projects. If you're trying to only do the normal compilation, then Eiffel will actually generate some temporary executable under W code. So let's say if you want to run your ETF projects before you finalize your projects, then you have to go into W code to search for the executable. Otherwise, if you actually somehow finalize your projects, because when you finalize your project, you will actually optimize the software to make sure it is run in the most efficient way, and also to discard all the assertions. But because you're actually going to compile, you have to keep compiling your projects as you fix any issues. So I would say you don't really have to finalize your code until maybe the last few versions of your software before the due dates. So for now, we are going to focus on the W code because so you don't actually have to finalize your projects for now. You can just keep compiling, and you can see that we are done with the compilation here. So there will be something generated under W code. And W code, you can see here, this is the executable that's generated, static analyzer. Okay, by default, if you simply try to launch this executable, it's going to launch a GUI. This is because if you go into the root cluster and the root class, you'll see that there is a feature here, as we said before, the switch called a switch. Switch is going to store the current mode for your ETF projects. By default, it's going to do a graphical user interface. But for your testing purpose, you might actually want to do the command line mode. Okay, that is why, as said in the instructions, you may first want to change this feature definition to be command line mode. The way to do that is simply just say ETF CL, and you would say show history. Okay, and you would just compile. Okay, just compile, and once you hit the recompilation key, and Eiffel is going to generate a new executable under W code over here. Okay, so now let's see how we can run this from the command line, right? So now we are in your static analyzer project directory. So now over there we have the ifgens, and we have static analyzer, and we have W code because we haven't finalized our project yet. We don't have to do that now. Okay, and then static analyzer. If we do that, okay, that's a good sign because now when we actually launch the executable, it has not launched the GUI, which is exactly what we wanted because we changed the switch value and then recompile. So now we're in the command line mode, And what we have to do is either to say -I for interactive mode, so you can actually keep interacting with your software as you develop your code. That's kind of handy. You can say quit to quit from there. Or you can actually do the batch mode. So we be -B. So when you say -B, so the software will be expecting a file, like a use case file. In this case, we can simply do at1.txt. Okay, if you simply do this, then it's actually going to output just default, because this is the default project that's generated by ETF. We haven't defined our business model just yet. That would be your task. So this is simply showing, okay, we start with some default system state 0, and then we do the reset, and we simply move on to state 1, okay, just the default behavior, okay? So that's the batch mode. However, so the batch mode, you can see that we only pass the use case file, at1.txt. Let's say somehow you want to redirect the outputs into another file. What you can do is to supply another argument. You can say at1.expected, or maybe in this case, you'll be more appropriate to say .actual.txt. This means when we say actual, that means that's the current output that's produced by your software. What you have to do is to make sure, let's do this first. Okay, so now if you go back to your directory, you can see that now we have at1.txt, and we have at1.actual.txt, and we have at1.expected.txt. So the difference between these three is at1.txt is simply the list of events that we want to run to test your software. So it's like a use case. So at1.expected.txt, this is some ideal behavior or expected behavior from your software. So ultimately, you want to make sure your software behaves exactly like this. And at1.actual.txt is the current behavior of your software. And the way to check to see if your behavior, your software behavior currently is correct, you can use like a command to actually compare them. For example, you can just use a diff command. If you're using different operating system, you might just be able to find some editor which you can compare the two text files more easily. But I'm just going to use the diff to show you. So if you say diff, and then you can say at1.actual.txt, so that's the actual output from the current software you have developed so far, and at1.expected.txt, so that's the ideal behavior we're expecting. If you simply do this, it's going to tell you there are so many differences between the two files, which is expected because nothing has been implemented yet. So eventually, you would expect when you hit this line, let's say you're using diff, then you shouldn't display any discrepancies between the two files, right? So that's the idea. Okay, so now let me see what's the next one in the agenda. So we have shown you how you can generate a new ETF project by using ETF-new into the current directory, and we show you how to switch to command line mode. So now we're going to show you how to add a new cluster in your projects. Okay, you have to do that properly, otherwise you will receive 0 because your project wouldn't be compilable when we receive that. So this is Eiffel Studio. Let's say I want to add a new cluster under, so most likely you should go under State Analyzer, and you can do whatever changes you like under this model cluster. It is called model because it's going to store all the logic and code for your business model, which is Static Analyzer. So let's say somehow you want to create a new subcluster under model. Let's say if you want to do that, the way to do that is, so this is the cluster structure here, and this is your file system structure here. So now you first have to create a physical folder in your system, and then you have to go back to Eiffel Studio to create a symbolic link as a cluster for that particular folder. So let's see how to do that. So for example, let's say we go into Static Analyzer and we go into Model. So now currently there's no subdirectory here. So let's create one. So let me just say structure, for example. You may want to use the structure cluster to store all your classes for the small expression language, for example. Okay, so now we have in the file system, we have a structure directory. If you simply do that, let's see, if you simply compile, it is already recognized. So actually you don't have to do anything. Why? let's go into projects and project settings, but you want to make sure it is set up correctly. So you can see under groups, under clusters, so now you can see that static analyzer is actually the top cluster you're trying to create. And now you can see that, oh, okay, you don't have to do anything because the recursive flag is set to be true. So any cluster that you add would be actually displayed over there. Okay, would be actually recognized. So there's nothing you have to do. So that's fine. Double check with one thing. So you can see that so simply the path is actually model slash structure. So that's relative. So you're safe. Okay, I just want to show you that how you can create a subcluster on the model. You just want to make sure if you're trying to add a new cluster, you always have to specify the relative path. But if you're trying to add simply a new subcluster under the existing cluster, because the cluster is already declared as recursive, so there's nothing you have to do. If you really find it necessary to create a new cluster at the top level, in this case, you will actually have to specify the relative path for that. For example, let's say I'll do one example for you to make it more concrete. So let's say so now there's a top level. So now let me say I have a cluster called tests. Okay. Okay, so let's say we have a cluster of tests. This tests directory is already generated for you by the ETF. So you got different subdirectories there. So maybe we can take this one as an example for you to see. So this is generated for you by default. The tests is not added as a cluster in Eiffel Studio, but how do we do to add it? So the way to do it is by go to projects, project settings, and we can say new cluster. Okay, now the name should be tests. Now the location, this is the critical part. So let's say if you simply want to browse, so you can say static analyzer and want to browse to the tests. If you say okay, now this is the problem. You see, the path you have over here is to say slash. So this is called the absolute path because it actually refers to an exact location in your file system, in your machine. However, if you simply just say OK and then save this, and when you submit your projects to another spot of the Indigo server, then this path would not be recognized, which means your project will not compile. Okay, so please pay attention to this. So first of all, you got to realize this is an absolute path, which is not supposed to appear in the location. What you are supposed to do is to say, I want to specify the location of this cluster here relative to your project directory. So your project directory is simply static analyzer, and which is represented as dot using the relative path. And now, because tests is directly under the static analyzer, so the way to specify this is by saying dot and tests. So in this case, the path is not absolute anymore. So this is relative. This is what you must specify, and you are responsible for making sure all the clusters you're creating contains paths like this rather than things like this. Again, if you simply say, I want to select this and add it, it's going to give you the absolute path by default. You have to make sure you must not have that. Okay, what you must have is like this. Okay, I cannot emphasize that more. Okay, do that. Say OK, and this should again compile. Okay, so let's see the agenda. So we also show you how to add a new cluster by using relative path as opposed to absolute path. So now, let's see how we can do some error reporting, and then I'll show you a simple pattern for you to follow. Okay, so now let's go back to our ETF Eiffel Studio here, and we're going to see that, for example, if you actually look at under static analyzer, if you look under abstract UI and user commands, under user command, you can see each of the events that is defined in this file here. It has a corresponding class. It's called a command pattern, which you learned about from the lab test. So now we want to make sure So let's say let's take one for example. Let's say for let's just add an addition, for example. Let's say here. So by default, we're simply going to call the default updates. So you can see that abstract user interface does not do any error handling at the moment. So whenever the user wants to call the add addition, the user will be able to do that because the model.default default update is simply called without any condition. Okay, so now let's say we're trying to do the following. So I'm just trying to make one example. You have to think about how that can be applied to your projects. So let's go to the default ETF model here. Of course, later on, you might rename this ETF model here to some more meaningful name or just create new classes here to suit your need for the projects. So default updates is simply here. Let's say we have some precondition, okay? So we'd say require the case that I, so we can only call the default updates if I is greater than 0. But initially, I is simply just 0. Okay, let's say we do some very trivial precondition failure, okay? If we do this, so that means every time, if you're trying to call this particular feature, currently all the commands over here call the default updates. Okay, every one of them. So the first one that you're going to run is going to call this default updates, which will fail its precondition. What's this going to happen? What's going to happen is we're going to get some crash from your GUI, from your application. We're going to show you, and then we'll show you how you're supposed to actually do some error handling. Okay. Please make sure you follow what I'm trying to say. If not, please rewind and watch that again. So now for default updates, which is called by every events command that we have here, we have a precondition which is violated by the initial states for the state attribute I. Okay, just try to make some example for you. So now let's say we are trying to run AT1. So now we are back here. So now we're in static analyzer. So again, we're going to say ifgens static analyzer wcode. And the program there, let's say -b, and then we'll say at1.txt. Okay, so now if you simply do that, you see now we actually have some precondition violation. You can see if you go to the top of the stack, they said precondition violated of the default updates, and this is actually quite expected, and this is actually from the reset of the ETF reset. Why? Because if you go to the at1.txt, you can see that the first event that actually occurred is actually reset. And reset, when the abstract user interface is reading this reset, it is actually going to go to the ETF reset feature reset class here, and then it is going to call the default updates without checking anything. Okay. So now, so what we should do is to actually make sure that we do some error handling here. So let's just try to isolate this problem here. Let me just create a new user acceptance case, because later on you have to create new acceptance case yourself as well. So let's say we have a new file, and then here I just have a reset over here. Okay, just one single event. I would say save, and then I'll go to where I saved that. So I would just say at0 for now. at0.txt, just one single event. Okay, so now let me just try to rerun that, and then now instead of at1, I'm going to say at0, and we still have the same precondition violation of the precondition of the default updates from the reset, which is called from ETF reset. Okay, so now what we're supposed to do, two things. So let me also open up our current ETF model, which is the business model. You might have different classes later on for your own model. Okay, so now, so here somehow we want to do some error handling. So I would suggest, so now I'm trying to show you a pattern which you advise to follow. Okay, we're going to say, let's say report items. So for example, you can simply have a list of string, and the string is actually going to show you the kind of error you might have. Let's say you can say start all with the prefix report. Let's say I, okay, not greater than 0, for example, because if you want to call default updates, I must be greater than 0, right? That's actually what the precondition is saying. So of course, if you have actually, sometimes you may have more than one precondition. Let's say if you also have s dot is empty. If it is not the case that s is empty, but initially s is indeed empty. Okay, so now I can I greater than 0, and here s not empty. So that means there are two possible ways to fail this default updates. Either you violate this precondition, and let's say if this precondition is not violated, but you violate this one. Remember, we have two preconditions here, and this is checked before this one. So this is checked after that one. So that means your error handling must actually have an order that corresponds to this order here for the precondition definition. I'm going to show you. Okay, so now we're going to have the report item there. So we can say the first possible error you might have is that report I not greater than 0. And this is syntax in Eiffel, which is to say, now I want to define this particular feature as an attribute. And just like how you define the query, but now rather than saying do, we're going to say attributes. So I'm going to say the attribute value is going to be set into initially some message. So let's say integer I not greater than 0. Okay, that's the error message that the user would be expected to see if they actually without. What they really expect to see is this error message rather than the stack trace like this. That's the point. Okay, so let's have another error message here. Let's say s is empty. Okay, so now we can say string attributes result equals, okay, string s is empty. Okay, so now we have two possible error messages here. Okay, and now, so these are the report items, and now you can actually make them only exported to ETF command, which means only the abstract user interface may access to these attributes. And then we're going to say set report. So this is where we set a report of the business model. So this feature will be called from the ETF command, one of the descendant classes of the ETF command. So we can say set report. So we're going to have some string over here. So the value should be one of the report items you define. So we can say here, so of course we're going to define the report later, equal to s. Okay, so here we have some attribute here. Report is actually simply a string. And initially, let's say it should be equal. Initially, you can say create result dot make empty. Let's see if I can do that. Okay, set report. Oh, we do have the set report already. Do we? Okay, let's see. Formal argument has the same name. Oh, I see. Okay, so because we have an attribute called s already, okay, just for this example, we can say report. Let's say new report. That's a minor issue. Okay, if we compile, okay, now it compiles. And then we got to make sure whenever the set report, whenever the abstract user interface sets the report to some error message, it should be reflected in the out feature, in the value of the out feature for this model here. So you can say, for example, that always you actually say result dot append. You can say now after that I'm going to put a new line, and then I'm going to do report. So of course you have to work this out yourself to make sure the generated outputs from your software matches exactly the outputs that are expected, that were already given to you. I'm just trying to make an example to you. Okay, so now we have set up the report setting mechanism in the ETF model side. Okay, that's a pattern I would like you to follow. First of all, you must have a attributes called report. Okay, first of all, you must have an attribute called report. And also for the report, for the possible values you might set to the report, it could be a signal of success or it could be a signal of error. For all the items, you should define them under the same feature section. Like say this is one possible error, this is another possible error. And then maybe you can also say report success. So this is when there's nothing wrong with your report, with your current interaction with the user. You can simply say OK, for example. And now all these should be exported to ETF command only, because only the abstract user interface is supposed to set the report. Okay, and I can actually also get rid of that. So everything will be under the same section. Okay, and the set report is going to be called from the abstract user interface side. And also make sure that report value is properly reflected in the value for the out feature. So now let's go back to one of the descending classes, which is ETF reset. You can see ETF reset is actually a descending class of ETF reset interface, and that one is actually descending class of ETF command. Okay, so that is why we put the ETF command in the export status there. So now what we're going to do is to say, before we can actually call this feature here, we have to make sure all its preconditions are satisfied. And the way we check it is by follow the order of the preconditions. Okay, so now we can say if model, we can say if, sorry, let me do it again. So now, first of all, so the first precondition is I should be greater than 0. So now we say if it is not the case that model.I is greater than 0, then we know that the precondition will be violated, and we're going to say model.setReport. And which value should we set it to? So it should be one of the report items we define, right? So here, one of the items we define is called report I not greater than 0. And we're going to come back and say set to the value of model.report I not greater than 0. Okay, that's the first possible error, because that's the first possible precondition that might be violated. And now we're going to specify for the second one. And the second one, you can simply use the if, else if. Else if it is not the case that model that, so it's a little bit funny because you can see the precondition itself contains a negation. Okay, I'll just put a negation anyway, but you can simplify that. If it is not the case that the precondition is satisfied, and the precondition is simply not model.s is empty. In this case, we're actually going to say model.set report, and then we're going to say model.report s is empty. Okay, you can feel free to actually simplify this to get, because double negation is simply equivalent to just positive, right? So now we're going to say if these two possible errors, which correspond to the two preconditions of default updates, if they are actually not violated, then we can safely call this here. And you may also want to, for example, to set the value of the report. You can say model.set report and model.report success. Okay, that's what you can do. Okay, compile, and now let's try again. So what we see now is we simply see, of course, the output. Well, output is not perfectly formatted, but you can see at least we don't have any exception, contra violation as before. So now instead we'd say, when we say reset, and the reset potentially can violate the first precondition for default updates, but now the abstract UI, abstract user interface, is giving the user some meaningful error message saying, yeah, you actually violate the precondition, so you got to try again without crashing the system. Okay, that's exactly what the error handling that is mentioned in both your lab test and your projects actually is supposed to be. So please make sure you follow this pattern here. It can make your life easier when you implement your projects. So you have to set up the reporting mechanism from the model side, and then so over there the features actually have the preconditions because it follows the design by contracts principle. But now in the abstract user interface side, for each one of the events, they have to program defensively, which means they have to appear as robust to the users. That means if the user potentially can make some error or damage the system, the abstract user interface, instead of crashing, it has to report some proper errors back to the user so the user can retry. That is exactly what we did. Okay, I think we have covered basically, okay, one last thing to cover. How you're supposed to, let's say you're trying to debug your ETF projects and how you're supposed to do the normal breakpoint setup and also to run the debugger. Okay, the trick is, let's say I want to make sure that I do actually set the report properly. Okay, just set up the breakpoint as usual. So we can go to flat view, go to the default go to the reset here. Okay, so now let's say we want to set a breakpoint here and see if we really goes into this branch and set a report properly. Okay, but now how do we launch the execution? That's the issue. What you gotta do is because now we are trying to launch the application from the command line rather than from Eiffel Studio. So what you should do is to do the following. So what you should do is actually do the following. So go to execution and go to execution parameter. Execution and then execution parameters here. And you have to say add here. And then for the arguments, you're going to pass exactly the same argument that you did on the command line. Okay, this is the arguments you have, right? So I'm going to do that. And I'm going to put it here. Oops. Okay, dash B is the first argument to say that's a batch mode, and we are trying to run at0.txt. Okay, now you can say run. Okay, if you want to stop at a breakpoint, you should not launch again from the terminal. I'm just trying to say you can run exactly the same options in Eiffel Studio as you did in the terminal. But if you want to stop at a breakpoint, you have to run from Eiffel Studio. Okay, so now, so we have set up the execution parameters properly, so now we can say run. If we say run, it's now going to pause here in the reset, right? If you see the stack trace over here, so you can see that we actually have different different features there, in the stack trace. And now the latest one, the reset, is exactly where we set the breakpoint. So now we actually want to make sure we do actually set up the report properly. So you can do the normal. You can, for example, execute one at a time. So now we do go into this branch, but we want to see if the set report is done properly. So now we can say go into the routine, and now we can say, oh yeah, indeed, it does set the result to be the value to be this particular value for the report item. Okay, and we set the report to be the new report, and let's just make sure from the expression watch that new report is indeed, yep, integer I not greater than 0. Okay, so we go there and go back and just keep going, and then eventually we'll get back to, yeah, exactly. So you can just run the code yourself to actually follow the execution flow. That's your job. But I'm just trying to show you, if you want to actually somehow, let's say somehow you're trying to run this on the terminal and you realize this particular use case actually gave me some unexpected behavior, then you can simply just copy and paste this option here and set it up back to execution and execution parameters, and then to see where the issue is by setting up the normal breakpoints just like before. That's how you debug your ETF projects. Okay, please make sure you also practice that. It's going to be very beneficial as your project grows with many classes. Okay, so now let's go back to the agenda. So now basically we have covered everything. Please review them and make sure you set up your projects properly, and that can save you a lot of time. when you do your projects, because it's a challenging project, but it's doable. But you want to make sure these small details, you do have to pay attention to them. Okay, so if you got any more questions, please post them on the forum or email me. Okay, stay watching.